I'm live? Okay, I guess I am. Thank you for everybody to coming back after lunch. I know that's tough sometimes, but at least I didn't get dressed up for nothing. So what are we going to do today? By the way, a little bit about myself, and that's the most boring slide from the whole presentation. So Piotr Mierzejewski, I'm a program director of development of DSX Local. DSX is the short for Data Science Experience. It's a machine learning platform developed by IBM that is coincidentally tightly infused and integrated with HDP, Hortonworks. So we do actually have a co-joint development pipeline where we basically merged, infused the industry-leading Hadoop ecosystem for your big data with the industry-leading machine learning platform being the DSX. And the solution of that is the DSX Local. I've been with this offering since the first line of code, so I'm immensely proud of that. However, I promise to limit the pitch when regarding to IBM side as low as possible. Okay, so that's a promise. Majority of the presentation will be basically about operationalizing machine learning and what does it really mean. Okay, and then yes, there will be few slides as to what IBM's position is and how DSX actually fills these expectations. So there is a couple of those in the end. There was a question earlier in the crowd, will this presentation be available for the download? Yes, it will be after the event itself. So if you intend to take pictures, I guess it's because of me. And feel free to do so. Try to not to flash other people. Now, another request that I've got is also that this session is being recorded. So if you do have a question, if you're closer to the mics, please try to come up to the mic. At any point in time, if you have a question, just raise the hand and I'll pause. I do tend to get excited and I speak a little bit too fast, so like just Peter, slow down. Anything like that, that's perfectly acceptable. If you're too far and you don't want to make a way to the mic, it's perfectly all right. I will repeat the question, so the people who will be viewing the recording will have a chance to actually hear it as well as my attempt at the answer. Okay. So without further ado, let's talk about operationalizing machine learning, or machine learning for enterprises, or machine learning in a production level scale. Now, there's a common misconception that people think machine learning is simple. And why not? Right? I mean, there's so many different open source libraries for the data scientists, the people that like R. There's RStudio. People like Python. They can go with the Zeppelin, Jupyter Notebook. There is a wide range of open source frameworks like XGBoost, TensorFlow, Scikit-learn. Why wouldn't it be easy? ML, traditional ML, when we talk about supervised, unsupervised learning, let's not get into the deep learning and neural networks yet, but this has been around for a while. So why would it be hard? Why, if executive's going to ask you, you know what, I want a model, can you get it to me next week? Why would it be hard? And for the data scientists in the room, and I just wanted to have a very quick survey, data scientists in the room. Okay, we got a few. How about developers? Okay, majority, and a business analyst, somebody from the business side of the world. Okay, now, this will not be a deep dive into machine learning models. Okay, we're going to look at take a little bit different style of the perception here, and seeing this, the work that you're doing, how come sometimes it's being underappreciated, and what considerations we have to take to actually take your models that you've created and allow you to work in a collaborative team environment governed by enterprises. Okay, this is the approach. So for the type of TensorFlow deep learning questions, I know someone in the third row is very interested in that. This will not be a deep dive. We're going to try to level the playing field. Okay, so the expectation is, okay, so I have this algorithm, and given I have my data, why can't I just throw it into the algorithm, and then magically, the model will be created, and then all I have to do to invoke it or score it, right? I have to provide my little X, and I'm going to get a Y. Okay, that's what people actually think, and that is what many minds of the executives, this is what should be it. The data scientist folks don't help the matter, because you guys can probably whip up a model in a day or two on your own laptop. Okay, you're going to get some public data set. You're going to, for example, create a recommendation engine. You're going to pull some data, create a recommendation engine with a k-means, and then, you know what, why not? Here it is. But now comes the aspect, how do I take this inside my organization? How do I expose it? How do I make it measurable, resilient? How do I make it scale? Now, to add to that, how do I make it actually collaborate? How can I actually give it to my other data scientists? How can we work together in this kind of in this environment? Now, this is what the really ML looks like. Okay, it's a vicious circle, and none of those steps. This is overly simplified, but none of those steps are actually simple. You have to think about the data prep. Okay, and when we talk about the data prep, we're going to talk about ingest. Okay, so I need to bring the data in because there's no ML without data. Those are just algorithms. If you don't have data, you're not going to have ML. Now, I have to explore this data. Now, when I'm thinking about exploration, so where is this data coming from? Is this relational databases? That's kind of structured. That I understand. There's schemas, right? So that's kind of explainable. But then you have Hadoop ecosystems. You have data lakes or swamps. Okay, how do I even make sense out of it? Where is this coming from? Now, cleansing. Ooh, that's going to get challenging. Okay, cleansing is going to get challenging because now my algorithms are great, but they don't like null values. Okay, there are sequences of IDs. I mean, those are not very useful. And what do I do with those funky strings? What do I do with some UTF encoding? Those are very valid questions. Now, feature engineering. Oh boy, how do I approach that problem? Okay, I have, so I've been given 200 columns of data from this relational table, and I'm supposed to write a predict function, but then do I have to go through every single one of them to figure out which one actually makes sense? Now, that's just the first stage. Then we're going to go into model development. So now I need to train this model. Wouldn't that be great if I don't have to do it on my laptop? Now, if I'm going to work with megabytes, gigabytes of data, yeah, we have powerful machines like this Max over here. They can actually process this kind of thing. But let's move into terabytes. Let's move into petabytes. How are we going to handle that? Obviously, parallelism, scaling, this is all critical. Tune and test. There's a wide range of algorithms, and some are better than others for a specific task at hand. How do I make it easy to actually select the correct one that is best fit for that job? That's going to give me the best training time, the best accuracy, the best area under the curve. Finally, the deployment and publishing. Like, I just done great work. I spent this time, I got this data, I've created the model, I know it's awesome, but how do I give it to the business unit? Because we have a business analyst in the room or an executive, like, what? So what do I do with this? How do I deploy it? Obviously, there has to be some standards. I should be creating some REST API endpoints. Do I have to write them? Like this has to return JSON, that has to come. This has to go where the application resides. Maybe for my batch scoring, it's okay for a couple second response times. But if we're talking about the credit card fraud, a couple seconds is not an option. Deployment, consumability, finally, the monitoring. Well, some of you might have heard about the model decay. Okay, that's a real problem. How do I make sure that my model that I know is accurate the moment that I've trained it and I've deployed it? How do I make sure that this model remains accurate without actually taking this down? So we'll dwell into each one of those a little bit deeper. Ingesting the data. Okay, so let's assume you know relational databases, you know how to use JDBC. Okay, you can write your subqueries, you can query your data sources. Now, do you even have access to those? Okay, do you think you can actually just come into the enterprise and say to your DBA, oh, I need access from that? Why don't you just open up your database for me so I can just query it? Why don't I just pull this data in because I'm so excited about my model training? Well, that is not going to fly. Your security, your governance, like GDPR, anybody heard about that? Well, when that's going to come into play 3 weeks from now, that's really going to make it even more challenging. But relational database is only just part of a problem. Okay, with the size, with the explosion of data that we generate, all from our mobile devices, from basically the social media, the historical data that we have, okay, everything that the applications are actually generating, our web services, all this kind of stuff, it's usually going to land in some kind of a data lake. And Hortonworks is great for that. They can handle terabytes and petabytes of your data. They can put it neatly and store it for you and make it accessible and queryable. But then again, how do I make actually sense out of all this? If I'm to spend days or weeks understanding where this actually resides, there's going to be a challenge. Could I not have some kind of a metadata catalog? How about a concept of shopping for data? When you're creating your models, what you're really interested in is actually something around the entity, the features that describe this entity, the problem that you're trying to solve. So essentially, what would be great if I could actually, the data could be tagged, and I can work on those tags. I really don't care where this data resides. Like, is it a relational database? Great. Okay, if it's a Hadoop ecosystem, great. Perhaps it's a Kafka message queue, right? So we have some kind of streaming data coming in as well. Now, we need to think of a platform that's going to handle all those type of use cases. And in a governed, auditable fashion that actually tracks the lineage of every single thing that you pull for your model training. Now, cleansing. Ooh, I've said that. But then, how do you cleanse? You can sample your data, okay? Hey, you can write a query, you can fetch the first 1,000 rows, but then again, you're dealing with 1 billion, okay? You can look humanly. If I look at a spreadsheet, I can look at 100 columns and kind of understand what's happening over there, and maybe like 1,000 rows if I spend half a day on it. And I can make sure there's not a null value. And I can make sure that those are IDs or those are just the serial generated numbers, and I can do some kind of conversion. Now, wouldn't it be great if the platform that you're actually working on allow you to actually summarize this and give you analysis of a report, statistical report, telling you how good your data set is? Now, wouldn't it be great if automatically it could, by you identifying your prediction variable, what do you want to really predict from this data set? So let's say some kind of a campaign, marketing campaign. Now, if the marketing campaign is a subscribe, and you know that this basically based on this data points, this has been subscribed, can the algorithm figure out for you which features can actually have impact on the actual prediction? Okay? Can the correlation be done by something else rather than you mulling through these data sets? Now, wouldn't that be easier? That would make it so much easier to actually extract the appropriate features. And this is just the first phase. Now, the second phase. The feature engineering, I just kind of got into that. Whoa, which ones are important? How are we gonna do that? What is actually impact of each specific column in your data set, your feature, on actual prediction? And the training. Okay, so I'm gonna have my favorite algorithm. Would it be a linear regression? Would it be random forest? Okay, would it be k-means? And then, I can sort my centroids, how many of them I want, how many centers. I can kind of do that, and I've created a model. But what is your assurance that you have selected the best model for the current data set that you're actually working with? It might have worked in the previous 8, 9 cases, but wouldn't you prefer to have a platform that will actually allow you to run multiple algorithms on a specific feature set that you've selected on the data set, and actually present you with a nice report of, well, the training, this algorithm is actually superior. But when it comes to accuracy and scoring, this is actually better. Now, we call it A/B testing, champion, challenge, and challenges. Champion and a challenger kind of modification. So a productionalized ML requires you to think about those things. Tuning and testing. So how hard is it, or how easy it should be to support multiple versions of your model? It is highly unlikely that you will get it the best at the first time around. And even if so, due diligence requires that you actually do it again. Test it again, try it something else. Do this kind of comparison. Train, retest, tune it up. Multiple version, backed by some kind of versioning system. That would work pretty cool. Now, publishing and deployment. Now, that's a nightmare. Each unique, so few things should be established out of the box. Okay? REST APIs. All right? Everything that's going to go out there has to communicate, it has to expose REST API, should communicate via JSON. That has been a standard for a while right now. Okay? It has to be secured. So every single model, every single asset you put out there, and by the way, models are not it. When I think about actual deployments, it's not only the model. What if you created some scripts that actually do some pre-processing of your data, or post-processing of your data? What if you have to identify if this is actually online scoring? Fairly simple. Request, response, this is our prediction, this is the confidence layer. Okay, that's good. How about for batch? What if you have to configure, there is this table that just gets populated every night, and they have to do the batch scoring through that. Okay, and then where I'm going to write the output to? Now, do I write the output on my laptop or on the server, or can I actually write it down to some kind of a table that doesn't even exist yet? Wouldn't that be nice to actually configure this kind of things, right? So it's beyond the model. This deployment and publishing, it actually goes beyond just the model. You have to think about it in the sense of any accompanied scripts okay? Perhaps even a notebook that you might want to run. Any related to batch processing, writing to the different data sources. Now, wouldn't that be nice if this was unified, not only for those that favor Spark, for Spark ML models, not only for R models, for Python, if I want to work with scikit-learn, if I want to work with TensorFlow, I want those models and those assets to be published the same fashion. And this is just in the space of predictive analytics. So why don't we pull in prescriptive, okay? Now you're going to use prescriptive analysis libraries, like for example, from IBM side decision optimization. It would be great if I can actually manage them in the same way. When I think of deployments and publishing, I'm actually thinking from perspective of a release. What are you actually publishing? It's not only the model that's been created, but the data assets that you've used to actually create it, any data sources you've defined, any scripts for post and pre-processing. This is actually a full-fledged release. Maybe it's an R-Shiny application. Now, all that has to be done in a governed fashion. And what I mean by governed is that, well, if I publish something, and it's not only about the deployment token that you can generate, right? So each invocation should be accompanied by some kind of authorization mechanism, but then you need to govern it from perspective, can somebody invoke this with that token that is perhaps a user of the platform, that is within my organization, that is within our network, or can it be invoked or exposed to just pretty much anybody with the link? If you as a data scientist were forced to do this work by yourself, to comply with those policies, now, this is not your expertise. Data scientists, brilliant people. Where you guys are good at, you're right here. You're in a feature engineering, you can do some cleansing, but that's just manual labor. Really don't want to do that. Now, the train, the tune, and test, awesome. But can I hand this over to somebody else? Ideally, I want to do it with one click. Okay, one click, not my problem. I've done my job. I've created your model. Just take it. Take it and just expose it somehow. Now, that's the shift of responsibilities. And we're going to get into the team sport concept of the machine learning in a second. Now, monitoring, essential. Now, monitoring in an easy way to be able to see, what is my latency of requests. Again, I mentioned a couple seconds might be okay for some use cases, but in others, nah, not at all. We're talking about milliseconds. You need to be able to take this and deploy as closest to the application as possible. As closest to the application as possible, and preferably for a batch scoring where your data resides. By the way, with the HDP 3.0 that's coming out soon, there will be Docker and Kubernetes enabled. So all those models from a DSX side are actually Docker containers managed by Kubernetes. Beautiful. Lightweight, deployed where your data is, or deployed where your application is. All right, just a little monitoring. And the monitoring goes beyond just basically seeing the accuracy of the model and response times. It goes basically for scheduling evaluations. How about that? I know as an enterprise, I know where my off cycles are. So I usually schedule my batch processing there. But then I can actually schedule model evaluations. I can point at the sample data sets or the new data that actually arrives, and I'm going to retrain my model. Okay, it's gonna basically, I can monitor it, evaluate it, and ideally, I might want to retrain it. All that has to be live. That has to happen without taking model down. Now, to add to this complexity, sorry, did we get here? Oh, wrong button, sorry guys. All right, so here we go. Now, all this, as this wasn't bad enough, now look at this picture. This is really what happens in enterprise, okay? So you are there, you're right there, in the center of it, and this is complex enough. But now you're gonna say, so well, existing architecture, IT architecture. So what we got? Some legacy systems, some AIX servers. We got some Linux boxes, Power, Z. That's the hardware that's been running the data. The data has been collecting the data for the last 50 years. now, to add to that, now we came up with this, the clouds are great. The clouds are great. So we have Azure. We got a Google Cloud. We got AWS, right? Then we have that they're all unique. They're great and unique. And you have a soft layer from IBM. And then you have your private infrastructure that lying behind, it's hidden behind a firewall. And if you're actually working on those servers, forget about access to internet. It does not exist. So now the platform needs to be able to deploy any of those. Deploying on AWS is easy. You can create some templates. EC2 would just spin up in a second. But then you have those bare metals, heavy servers that have been around for ages, where really nobody can access this. How do you address that? Now, this per skills. You're going to talk machine learning to your DBAs, they're going to be looking at you like, no. And even within your data scientist teams, individually, you're a master of your domain. But data science has been growing to exponentially. The number of libraries, if we look at the Conda, I mean, there's thousands of packages. You look at Python, you look at R, you might be a statistician, and your R is your preference. Others might say, you know what, this Scala thing looks so cool, right? I want to try it out. Now, so you have a team of people, ideally geography collocated, but that doesn't really happen in reality. Okay, and then we have to agree, how can we work? I want to work on Scala, I want to work on R. And I like Python 3.5, and I like the TensorFlow, So everybody's like, yes, it's not a dim sum lunch. No. But yet, the platform like this has to support it. The enterprise has to realize, you know what, hey, to retrain these guys, to actually force them to go to something that we decide to use, because thou shall use Python 2.7, well, it's not going to work for half your team. To retrain them, data scientists, it's tough. We're resistant of change. We often are. At least if we find something we're really good at and it actually works. So why would I start using something else? Now, data and applications. So processes, groups, and teams. Oh boy, everybody loves processes, right? To go to risk hardware, so like, where is my servers going to be running? Because right now, I'm going to be digesting 20 terabytes of data, and I need to have minimum 64 CPU and about the half terabyte of RAM. I'll give it to you back in a week, but right now I need it. What is the process right now in your organizations? Personally, I know that I've heard from various customers, well, it's going to take me 3 months to get those VMs. Well, executives not going to like that. And this is not even talking about the inside of this. We're just talking about the peripheral things. This is you working within your own organization and a process that has been established for very good reasons, I'll bet. However, they're not helping the whole, I want my model in 2 days. That's not going to be that easy. Data and application silos. So you want to expose this. You want to expose your model, but then, we go back into this deployment publishing part. But then it turns out that each business unit is using different methodologies. They have applications running on different servers, and they actually would like for one to be XML, one is JSON. Oh, it just gets a nightmare. Now, business process compliance regulations. This is kind of, I highlighted the GPR. It's not a joke. You need to be explained. You need to be able to explain what data your model used. What did you do with this data? If we're handling some personal information, there has to be a trail, audit trail, for every single piece of code, information, the data that you used. How did you use it? And that goes even beyond that. It goes about what algorithm was used to actually create this model. Okay, what is the performance of this model? All those various pieces. Now, that's what real ML looks like. Okay, so this is not a 2-day effort. To work within these parameters, to be able to actually work effectively and expose your work and be efficient, this is a huge challenge. So let's look kind of why is it challenging? Well, you want to act on the real world data, right? You can practice, you can do something at home with and the real world data is not gigabytes, it's not megabytes. We're going to talk here about the terabytes and petabytes of data. This needs to be scalable. You need to have a platform that actually handles this. Now, you need to be able to act and have impact on business as events actually occur. Not everything can be reactive in a sense, right? This is predictive analytics. Predictive analytics. You need to be as close to these applications, as close to the source where the data is generated to be able to provide the response. Then transactions and decisions in a closed loop. Okay, so this is going to keep repeating. Do you think if you're going to go through the previous demand circle that we actually talked about, you're going to do it once and you're done? Nope. That's not going to be like that. The things will continue changing. I mentioned model decay just briefly. Well, your models, your data will change. Your data will change, it will constantly be changing. You need to be doing this in a closed loop approach with minimum interactions from yourself. Now, we do have a kind of solution to that. And then on a very high level, When you think about ML, I want to think about 5 pillars, 5 foundations on which you have to think about to actually build operationalize your ML. I use pillars because I cannot really pronounce this 10th. I don't know. So there you go. Now, managed. This talks about analytics, read-only data. Read-only. Yes, you can persist your data frame, okay? Nothing stopping you from outputting and storing the data somewhere, but at that point in time, unless you have a lineage and you can delete it when, for example, customer leaves the organization, you're in trouble. You're violating GDPR. Those are actually very, very heavy penalties. So understanding this, we're going to do, by the way, I'm going to get into the details about each, so I'm just going to go on a high level right now. Now, quality, explainability. This has to be trusted. This has to be trusted. Resilient. Now, one model is fine, but what if the server goes down? Can an organization afford for the model to be down until the dev IT actually gets to it and starts rebooting VMs and debugging? What if your storage is corrupted? What's going to happen then? Now, what if suddenly your app is a success and then from 1,000 requests per second, you're getting 1 million requests per second? What's going to happen then? How are you going to scale your model? To ensure that there is actually just like as the SLA says, this has to respond under a second, right? So this comes resiliency, measurable. We talked about this. And you will find that from a high level, as I dived into this, I've mentioned some of those things, but I want to basically dwell into this and how important those things actually are. Measurability, so monitoring and measurement of your model performances. And then finally is evolution. They're not set in stone. Okay? The models are not set in stone. Your data will change. There will be new algorithms. There will be new ways of doing things. There will be different requirements from your business units. Okay? You need to be able to essentially run multiple versions, take one down, transfer the traffic to another. How are you going to do all that? All right, so where is my data? Well, as a data scientist, it is unlikely that you will ever be given a full picture as to where the data resides. You'll have to go through the pain of dealing with the DBAs and then going through the processes and organizations to figure out, okay, can I even access this? Do I have a rights viewing? Like, I forget about modifying this thing. But do I have a right to actually even view this data and use from my model training? Not necessarily, right? There is ways to go around it. They might actually, create some kind of a views for you. They can extrapolate this. They can anomalize the data, right? Hide the sensitive information. That all takes time. The concept of a metadata catalog, when a data scientist can actually shop for data, it would be a solution to that, right? At that point, you're agnostic as to where the data resides. Every request is logged. You're authenticated that you're actually using it, but all the permissions and everything has been configured for you. Data virtualization, automatable pipelines for data preparations. This is something I started with these scripts that you guys might write. Okay, so that's why when we talk about models, it's not only the model itself, but how do I prepare my data? The new data will come in, it's unlikely that it will be clean. I need to be able to automate this process to the point where I actually create my production release. It will be able to connect from the data sources that I have to pull the data from. It will be able to aggregate it in case if this is a streaming source, if this is a relational database, Hadoop data lake. You should be able to use all of them to train one model. Why not? Okay, and then how do I automate it and actually deploy into production? Sorry, I'm just going to check how I'm doing on time. Okay, sorry. Trusted. It seems I'm going to have to speed up through those things. Lineage of the model, and then transformations and everything. Basically, all that you have done to create this model has to be auditable. You need to be able to explain how you use the data, how you transform this data, okay? If you persisted anything, if you actually stored it, all this has to be auditable and it has to have a lineage. Now, how do I get extra compute resources? How is that platform scalable? That is also very, very, very hard to do. Now, at scale. So now we're talking reliable, resilient, ensuring the low latency. How easy it is for me to decide that I want to reserve certain amount of CPU and RAM for this model or this release, and how do I ensure that this is always available? It has to always be available. How do I ensure if one of the servers is down, that automatically a new instance of that model will be deployed on the next available server? This is the questions you have to ask yourself. Finally, measurable. Well, this is actually one of the easier part in a sense that you can run the request to the model, you can measure the latency, right? You can basically set up the evaluation, measure the number of requests per second, per day, and then act accordingly. And then finally, monitor for health, and ideally retrain the model while the model is operational. Versioning, delivery and improve. So growth and maturity, this all counts as a part of evaluation. Hyperparameterization, can I add that? So for example, how deep is supposed to be my tree? Okay? How many k-means, how many clusters would I want to have? Can I set this up in my pipeline? Automated retraining and deployments within the same cluster. Can that be scheduled? Can it be fully automated? Can I set up some jobs that will actually run at a specific time of the, of the day, for example, conceivable future, and will do this for me automatically? All good points. Now, all we've mentioned, let's just add a couple personas here. Let's just add a couple dimensions. Again, because data science is a team sport. As a data scientist, it will be impossible for you to know and to do all this without engaging different personas inside your organization. The exec has an easy job, right? I mean, he's just going to say, I'm going to give you a problem statement. But that's critical as well. Your success will be judged by how these people actually feel. Have you resolved my business problem? All right? It's like this old cartoon of building the swing that doesn't really work and everybody is just confused. So this is the way this all starts. They're going to give you a business problem. Then you actually have to talk to your data engineer. These people understand where the data resides. Okay? They're going to actually help you set up those data sources. I use it for purpose because that's what we use inside DSX. Set up those data sources, kind of configure where the data is going to come from, give you the appropriate access. So you can actually do your work. Now, this is where it's kind of come in, is this training models, feature extraction, collects and preparation, persistence of data. This is where you're going to come in. This is the one this is the heart of the whole operation. But then finally, you're going to have to hand it over to the admins, dev IT, and operations teams. This is not your cup of tea. You don't know where those servers are. How do you expose the security? This is not your work. So it is a team sport. There is multiple roles for the ML to be successful in the production. You're in the heart of it. You're data scientist, you're in the heart of it. But the platform has to enable you to effectively work with your executives, bless you, with the application developers, your ops, your data engineers, and finally you're there. You're the glue. We had a vision how this could be done. Now, many things that I will make statements about the DSX and the platforms that are out there. Many of that has actually became possible when it comes to resiliency, scaling, reservation of resources, because of this awesome open source technology, Kubernetes. Everybody heard about Docker? I'm just going to set it. Yes, come on. You guys heard about Docker, good. Have you heard about Kubernetes? Orchestration, good, that's better. Because I have all those developers in the room. I'm like, no, I didn't hear about Kube. No, I've been hidden under the rock for the last, 3-4 years. So yes, Kubernetes gives us quite a few amazing things that allows us to build platforms as software that enable data scientists all those wonderful things that we actually do. We can set up the network policies that give us service resiliency. Kubernetes Docker can restart the container. Kubernetes can actually tell us that the service that's running inside a container has actually died via liveness or readiness probes, right? We can have Kube, for us, just deploy it. The moment the node goes down, no problem. If I have another node labeled with the same type of application, Kubernetes will actually scale it automatically for us. What it can also do for us, well, it can reserve space and resources, resources, like CPU and RAM. It can always ensure that on that node, this model or this release will always have 2 CPU and let's say 16 GB of RAM available regardless of what happens. Okay? It gives us HA on the storage layer via GlusterFS. It gives us HA on a service layer because it will continue redeploying them and trying to restarting those containers. It will allow us to do isolation between the development and production because we can label hardware the way we want to, and it will actually honor those. It will set up security policies for us. And so where the unique value is, so you guys embraced Kubernetes. Yay, IBM. Well, this is a big change. This is a huge change. IBM has 350,000 developers around the world, okay? Can we create container services? Yes, we can. Can we do it better than Google? Perhaps not. Why would we? Why would we start redeveloping Python and R and IDEs for the data scientists and container orchestration? We embraced it. That was a huge shift. That was a huge shift. And we took the value proposition to somewhere else. Now, we bring in all this open platform, right? We allow you, what we bring in, allow you the teaming part. You know, this whole data science is a team sport? Well, why don't we help you do that? Why don't we enable you to actually connect and configure with any LDAP or SMTP servers or any kind of versioning system your organization might have? Why don't we generate, for the data preparation, why don't we allow you to securely connect to any type of relational Hadoop data lake, any kind of streaming application data, and allow you to persist them and share them in a secure fashion? Why don't we allow you to, not allow you, but actually let's just bring in all the various tooling that you have, and regardless if your data scientist is R, Python, Scala, using SparkML, or is using Python, let's say XGBoost, or TensorFlow models, why don't we allow you to actually manage them within the same type of releases and offload this whole publishing business to a one-click operation. One-click operation. And then the DevOps guy can just say, oh, hey, this has to run in 3 instances. Okay? So this is essentially where the value proposition has actually switched. This is what I've been focusing for all this time. Now, what do we allow you to do? Well, we can allow you to explore scale out on demand. No DevOps engineering. Okay, you can basically, you want to scale the cluster? Okay, cool. Add another EC2 instance, and then you know what? We'll just lay out the kube for you, and we'll start scaling that, and you can actually have those resources. GPUs are expensive. Yes. So do I have to have a GPU all the time? How long will it take me? If I have to do the deep learning model, how long will it take me to actually bring this kind of node in and do my actual neural networks? Okay, well, it's about 30-minute operation. 30 minutes, and you have yourself a GPU node attached to your platform. Security, huge part. I'm not going to dwell into that, but wouldn't it be great if we can just offload it, this mass to somebody else? Okay, unification, extensibility. Now, the platform can pre-package, let's say, full Anaconda distribution, Python 3.5, you know, those libraries, but there will be new libraries. And as unique as you are, as each data scientist is, I have my preferences. How can I add those to the platform, contribute them? I know I will do that. But then when it comes to the model deployments and sharing those across the different environments, how can I ensure that they're actually shared? I see I'm so running out of time. So in the heart of it, data science experience. All around it, what's infused, you might probably know that. So definitely Apache Nox, Hadoop. Yes, you are in a Horton Work conference, so you should know that. You see the Zeppelin. If you're using HDP, you will be familiar with it. Now we talk about Scala, scikit-learn, TensorFlow, all Python. All embraced, all integrated in a one unified experience. That's a busy slide. Collaboration, isolation, allowing you to essentially not only look at the models as a serialized or a PMML format, but everything that's surrounding. So any kind of data wrangling scripts that might you want to use. Portability of it. Oh, I haven't even touched on that, but how about remote scoring? You've created a model within the platform. Now you want to be able to deploy it where it's actually where the applications are. Versioning and publishing of the different assets. Now you need to be able to trace back to what you've done. The Git naturally comes in mind. So the Git has to be natively integrated into the platform, whatever you do. Or if your actual organization works in external Git or Bitbucket on a GitLab, well, you should be able to actually work in there and just sync it up with the platform, all right, and actually deploy those assets. Should be as simple as a push and pull. Yeah. And finally, CDCI pipelines, maybe not the greatest interest. to the data scientist, but yes, it has to be integrated with that. And that's, well, now we move to the part about where IBM plays a role and the data science experience. For the brevity of the presentation, was only 40 minutes. I couldn't do the full live demos. So essentially, we have a couple of screenshots, how we envision this to happen. Uniform view of all your assets. And within that, you have your environments with the full control of the resources. You have your data sources, collaborators. You have your jobs, kind of a transient workers that will just show up magically containers and run your jobs and disappear, so you don't have to worry about resource management. And all unified view of that. So your models, your studio scripts, your notebooks, everything versioned and available in collaborative fashion. Another aspect, visualization. So R, Python, Scala, anybody, IDE, choose the one you like. Again, managed, again, in the same environment. Environments. So full control for you, how much CPU and RAM you want. And it can differ between every single project you work with. Even the environments within the same project, you have a full control how much resources you want to give it. An environment that will tell you how much is really available and how much your friends are using. All right? Also, options of doing dynamic allocations. Extensibility. Okay, well, so this is all Docker images. So if you want to add some packages, well, it's as simple as actually downloading one of those images, adding additional Docker layers, doing pip installs for conda RC files, and saving it. And this is, it's available on the platform. And you don't have to worry that this was something that you've created. It's available for your fellow data scientist. It's available for your releases when the model actually are deployed, or even as far as pushing it into HDP cluster. No longer limited with the current release of the DSX and HDP. I believe it was the 2.64. You're not longer limited to SparkML. You can train scikit-learn models in parallel on your HDP cluster. There's a mechanism that we actually package all the required libraries, and we actually ship it to that HDP edge node, which is then distributed by Yarn. Very cool stuff. Jobs, transient things. This is for your batch calling, model evaluations, retraining of the models. Like, I want to set it up, and I will just run it, and I don't have to worry. All I need to is just the reports to get me back. Monitoring of your models and resource utilization. Okay? Training the model and having alerts right away when you know the evaluations are poor, good, and by the way, those are something that you set, that you would set. You set those thresholds, then the platform takes care of the rest. And creation of the releases. And the release being, as I mentioned, URL generated for you, deployment token generated for you, various assets exposed as applications, web services, or actual jobs. Selection of the workers, environment, and then how many replicas of this one? How many replicas of the model do you want of this kind of release? It's as simple as that. And then the platform ensures that it's essentially ELA. You want to make sure that there's always 2 instances, and there will be. Okay, various scripts as the web services, and that's, by the way, how this would look under the hood. That's a very busy slide. I honestly don't have time to go over it. However, this will be available for download at a later time. At any point in time, if you would like to try out the DSX, there is a public cloud version called Watson Studio. This is free to try. There's a desktop version that runs on your Macs, on your Windows machines, as well as on the Linux laptop if you happen to have one. And finally, there's DSX Local that is for enterprises, which I was just showing. However, just to try it out, there's a various types of offering that you can do. Try it for free to get familiarized with the platform and the framework. And to leave you with this, ML is fluid. It is constantly changing. It requires multiple personas within an organization to actually do it right in a production environment. So remember the 5 pillars: the managed, the trusted, resilient, measurable, and be able to devolve. Thank you. All right, just in time. Was there any questions? You're just going to run away. Okay, thanks.